Hi, I'm James McGuire here at AWS reInvent. I'm talking with Evan Kaplan, Chief Executive Officer of InfluxData. Evan, thanks for talking with us. And wow, there's a lot going on at reInvent this year, isn't there?
There is. First of all, thanks for having me.
Sure.
Yeah, I think I feel like over the last, reInvent's become the premier event, sort of replacing years ago Comdex and even to some extent CES because so much had moved to cloud computing. But I think last 2 or 3 years, the let's call it the AI revolution has really just ramped everything up to a different level of intensity. So yeah, it's exciting.
Yeah, no, there's a lot going on.
It's a little crazy, but it's exciting.
It is crazy. Time series data, really a hot topic these days. I can't believe how much has exploded in terms of time series data with edge computing, with AI, with Internet of Things. Why has time series data gotten so big in the enterprise these days?
I think it's the interesting thing. I think it's probably been big for a very long time. But if you did this 40 years ago, you did it on an IBM mainframe, right? If you did it 20 years ago, you did it on an Oracle database, and still we replace many of those, even in a because the fundamental need for time series has always been there. You just used a general purpose database to do it. What's happened over the last, I don't know, probably 8 years in a meaningful fashion is that people have moved more to these specialty databases. And that's not just true of time series, it's true of search, it's true of graph, it's true of document, is that the more intense the data flows become, the more specialized you want the databases to be to handle them.
Okay.
And then you have these lake houses that emerge to integrate all that later. So it actually is a pretty healthy ecosystem.
Okay.
Where you've got these specialty databases eventually feeding lake houses.
Right.
So time series is one of them. But really the really big driver is two big trends. First is, the plethora of sensors getting deployed.
Which is just countless.
On your body, in your cars,
everywhere.
in your buildings, in your traffic, in your
I think
cities.
I'm wearing 2 of them myself right now.
Yeah, I'm sure I'm at least wearing 2 of them. And so you have that plethora of sensors going, and sensors speak time series. That's the lingua franca. So pressure, volume, temperature, humidity, light, heartbeat, whatever it is, it's measuring it over time as a vector. And if you know that time is your primary vector, right, you can really organize that data to be super, super efficient. And so that's what a really good time series database does. Obviously, we think we do it the best, but there are other people who compete. And so what's driving that is we're seeing this IoT dynamic driven by all these sensors. But it's not just physical sensors. It's virtual sensors. It's, earlier today we had a conversation with Ninja One who uses Influx, where they're instrumenting laptops and things, the software to see if their agents and patching are up to date. We have a lot of customers who do network telemetry. So a lot of virtual sensors too. So think about physical sensors. That's the first level of stuff that drives time series.
Okay.
When you're instrumenting. The second is relatively, and this ties into our AWS question, is the emergence of AI. So if you think about the physical world, right, there's a limited amount of data that's available in the digital world, right? And so that's why people are doing more and more synthetic data. Right? But in the physical world, depending on degree of resolution, it's infinite by definition.
Okay.
By definition, right? Almost grains of sand in the universe, right? Like you're constantly, and particularly. And so if you want to instrument the physical world, you want to do it at a high resolution. If you want to build sophisticated systems. And so, for instance, our default precision is nanosecond.
Wow, okay.
Now, many people need to connect a nanosecond.
All right.
And most people adjust it to be, 10 milliseconds, a minute, 10 seconds, whatever their application requires. But the idea is that if I can get a high-resolution picture of the physical world, then I'm going to be better at building intelligence around it and automating it. And so time series is the key to that automation.
Okay.
So if you take, an example we're all now very familiar with, a self-driving car.
Sure.
You start with a car, you start with something, you build sensors collecting the data. Sensors are all based on time, right? They could be images based on time, they could be, pressure, they could be traffic, could be sensors, proximity. Right? And you instrument it, and then you put the car on the road, and you see anomalies, and then you fix the anomalies, and you re-instrument it. And then you do that again, you fix an anomaly. You do it I don't know, 4 billion times, you've got a self-driving car.
Where you have the information needed.
Right.
Yeah.
You have a self-driving car, and that's the journey of intelligence and automation. Because all these human design systems, they want to be self-healing. They want to be self-adapting. You know, if you have a Nest thermostat in your house, it wants to. Sometimes it screws up,
Right.
but it wants to do. And most things we do, when you think about robots or you think about things that are coming, we want those things to be automated, which can be automated. And so that time series is at the core of that automation.
Well, you talked about some of the trends driving it. I want to make sure we don't miss any trends. Are there trends that customers need to know about as they're deploying time series data?
I think there are things I think most developers start building applications on databases they're familiar with, which are generally some sort of relational or NoSQL database. I think as you get more sophisticated and you really see what kind of service you're building, application, automation, more and more people are starting with time series. You know, when I started with the company in 2016, we had about 3,000 sites running InfluxDB worldwide. Today there are 1.4 million who run it daily.
Okay.
And so everybody's, people are everything from the most sophisticated companies like Tesla, Siemens, Honeywell, Cisco.
They're all using it.
Right? They all use it to people using it in their house to actually instrument a variety of sensors, thermostats, pool temperatures. And it's, that's what we love about the open source is that ability to use it that way.
Well, all right, so certainly physical systems need telemetry to move autonomously. How does time series data help drive that, and what do businesses need to know?
So businesses need to know that no application they build is static. And that every application or service or system they build wants to get increasingly autonomous over time, smarter, self-healing, and eventually completely autonomous.
Okay.
And the pathway to that is deeply, deeply understanding the system. And the pathway to that is getting a higher and higher resolution picture of what's happening. And so, if you've got a Tesla battery power pack, one of our larger customers, right? And it's operating in a home. You want to understand basically what that cycle is a day when it's storing energy in it, so that when you can trade energy back to the grid, you have a 4-second window to do it, and you can do it. Like, you just want that information. The more you have, the smarter you can be, the closer you are to increasing intelligence and increasing autonomy. And that's the journey. So not all systems need to be autonomous,
right?
But all systems want to be.
What about the partnership with AWS, InfluxData and AWS? I mean, how does that help your company?
It's been actually really helpful, and they've been a great partner. Historically, AWS had gotten some bad press associated with, taking open source databases, monetizing them, and not contributing enough back to the community, and people feeling so a lot of companies changed their licenses to prevent that, and that ended up forking databases. It ended up with just sort of a bit of an ugly world. But they approached us a couple of years ago with a really novel approach that they have stuck to and have been great, which is they license our open source, so they pay us to run it, and pay us to support it, and then we get to build value-added stuff on top of it, which we then monetize, and it's just a really generative relationship. And I was a little bit skeptical when we first had the discussions about it, but they've been a great partner, and obviously expands our distribution, and for them, if they can get these time series workloads on AWS, then they have everything else to sell: SageMaker, Lambda, other databases, their Redshift.
It helps them, for sure.
It builds, it gets, data has gravity. If I can have data on my platform, I have the ability to add value.
Data has gravity. That is certainly true.
Yeah.
Developers. So what do developers need to know? And I think developers are an interesting audience because when developers really like a product, they really give it momentum. So what do they need to know?
So obviously we've had momentum, and it's been sustained over at least the last 8 years. I think they need to know increasingly when they need to start their projects with time series data. Not just ours, but even our competitors or that sort of stuff. Is some projects just cry for it. And so the issue is sometimes developers are really comfortable with what they've already used.
Sure.
So we've done everything we can to, basically get to the hero moment very quickly. The database is schema on write, so it's super flexible. It uses SQL or a query-like language. It's pretty easy to learn. It integrates with Python. We've done some stuff that just make that developer experience. And then, of course, it's open source.
Right.
So they don't have to talk to anybody. And a lot of times developers don't want to talk to
Developers
commercial
like open
entities.
source, for sure.
Yeah,
Yeah.
they want to start there. They don't want to have to talk to somebody just to play around and figure out stuff.
What about the future? I mean, where do you see time series data going in the next, say, 2 or 3 years? What will it be capable of?
I think it'll grow very consistently and perhaps even be explosive. And I think the largest driver are the two things I mentioned. Physical AI becoming more and more important, everything from robotics to space to energy to all that sort of stuff. And then obviously the IoT.
Right.
That has been just ramping up. We're not having less sensors in our life.
No.
We're not having less sensors in our communities.
It seemed like IoT, before AI came along and took all the oxygen from the room,
IoT
people was very high, but IoT didn't actually go away just because AI is here. In fact, if anything,
No,
it
in
keeps
fact,
growing.
they're deeply related.
Yeah.
You want to build control systems, you need sensors.
Definitely.
You need sensors, you have IoT.
Well, I want to make sure I ask you about the new version. What do we need to know about the new version?
So we've had a significant evolution. The new version, InfluxDB 3, we've been running it for about a year for customers. Amazon has been running it about a month and a half, so we're super excited about it,
Okay.
the latest version. And it's a really a fundamental rewrite of the core database. It's rewritten in Rust, which is a memory safe memory safe language that makes it really fault tolerant. Two is it now supports native SQL. So any of the SQL tools you use, you can generally use with Influx, including some of the business intelligence tools, things like that. Three is it handles infinite cardinality. And so cardinality kills time series databases because cardinality is basically a multiplicative factor is how much do I want to know about this sensor reading, and then how many sensors do I have? And so as those expand, it's exponential, and that can choke a database off if it can't handle that cardinality. We saw that in 1 and 2, that we get up to levels of a billion or so cardinality measurements, and it could start to really hurt performance. And so we built a new database that have unlimited cardinality. And then perhaps one of the most important things is we separated compute and storage. So those can now scale independently. And so you can really run, if you have long-term retention of data, you can really run a very total cost of ownership efficient process. And the last thing which we're really excited about is there's a native Python processing engine built in. There are triggers in the database, so you can write anomaly detection applications. You can write time series forecasting. You can write predictive maintenance. You can write downsampling. So you can write applications directly on the data. And this is very uncommon in the database world. Usually those are separate things.
Okay.
But if you can do it, and you can do it in real time, sub 50 millisecond time for these things, it's a very powerful implementation. So I'm excited for developers to start building around that.
Interesting.
So lots of stuff in this latest version.
Yeah. It's not just a new little upgrade. It sounds like
it was
a major rebuild.
We've been working on it for 4 years. So.
Evan, I think you said it. A lot of good stuff. Fascinating. Obviously, the sector is going to grow. Let's talk again sometime.
Yeah, man. Thanks for having me, James. All right.
Thank you.
Take care.